Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. Today, it's another installment of big ideas and little-known facts about connectors with John Sandy of TTI and Molex's John Crimmins.
Thanks, Jim, and welcome everybody to the Molex TTI podcast series, Big Ideas and Little-Known Facts in the World of Connectors. My name is John Sandy from TTI, and my co-host today is John Crimmins from Molex. Hi, John.
Hey there, John.
Our guest today is Pat Killian, Senior Global Product Manager for High Power at Molex. Welcome to the podcast, Pat.
Hey, John. How you doing? Thanks for having me back.
Great to have you on again. Why don't you start by just reminding the listeners who Pat Killian is, what you've been doing at Molex, and what you're up to these days.
Sure. So I started off life as a manufacturing engineer. I started as a mechanical engineer, and I moved into sales in the 90s and spent about 10 years on the street as a sales engineer or as a sales manager. I moved to our international group for a couple of years and did international marketing. I went to product development in the early 2000s, and then I went back into sales for 6 years in an international assignment. And then after 6 years of that, in 2012 or 13, I moved back into product development, and I've been in product development ever since.
So that's a good rounded set of experience there, Pat. Do you feel that really helps you when you start looking at product development and what might be coming down and how best to sort of promote that out into the market and to the Molex sales team and also through the distribution channel?
I think it did, John. One of the things whenever I'm talking to a young person and talking to them about their career, I recommend you should make options for yourself. And I think my career helped me do that because I did so many different things early. It allowed me to move into different positions later on. It also, when I got into product development, both times I was in product development, I went and developed the products that I wanted when I was in sales that we did not have. And once they gave me the keys to develop new products, I ran with it. So it was a lot of fun, or has been a lot of fun.
Very good, Pat. And you've been a big part of the Molex recent success, 3 to 5 years, in my mind, of our growth in the high power industry. Can you define how Molex thinks of high power?
I think that most connector companies think of high power, we think of current. And we set a threshold and say any current above this level is high power. I don't think that's the way our customers think about it. So I try and think about it the way our customers do. When they think about power, our customers are generally thinking wattage, not amps. So it's a combination of what the voltage that they're running, what their system voltage is, and what their current needs are. They just multiply those together to get the wattage that they look for. So when I'm looking at high power, some of the products that I'm developing do have high current, but I really spend a lot of time thinking about how we can increase the voltage so that the total, so they get more kilowatts out of through our connectors. So that gives you a rough idea. From a current standpoint, Molex thinks anything above 50 amps is high power. From a voltage standpoint, I think anything from 400 volts and up is high voltage, though most of the products that I'm developing are for 1,000 volts or 1,500 volts.
That's an interesting concept, Pat, to think of in terms exactly of how the customers look at it. And I think that's very refreshing, and probably our listeners will appreciate that. I'm just trying to get a feeling for where you think the customers' needs are today, where they've come from, and where they're going when it comes to power. Because obviously, I have a team of 5 business development managers out in North America, as you know, and my team often sees that there's a massive sea change in what customers are looking to do now. They're looking for more out of a smaller package in a lighter package, and there's a lot of challenges involved. So could you sort of explain maybe what are the trends in the industry you're seeing and how that's driving product development inside of Molex?
Sure. Thanks, John. I think there's 3, I'm going to call them disruptive technologies. I know that this gets used a lot in the news, but I think obviously we're all familiar with what's going on with AI and how that is impacting the data centers and to a lesser extent the telecom centers. But So there's a huge increase in wattage because there's all these GPUs now on the boards instead of CPUs, and they take about 4 times as much power to run a GPU. But that's what we need to do all the math to make the AI systems work. So there's a huge increase in demand. It's at the same time we want to make things smaller. So you don't want to make a bigger connector. That's why we're going to higher voltage connectors. And there's things that we can do to make a connector the same size as one we had 4 years ago, but higher voltage. And you multiply the current time the voltage and you come up with the watts. So AI is driving a trend towards higher voltage. The EV market, we're also developing products for EVs and the EV infrastructure, the charging stations. And on those, it's really just a voltage play. The systems that were, I'll say a 2021 car was probably running at 400 volts. We're talking about from the battery running up to the motor, and there's an inverter in between that goes from DC to AC. And today they're more like 800 or 1,000 volts. And the reason that they're increasing the voltage is because every time you double the system voltage on a vehicle, you cut the charge time in half. So from if you're at 10% charge and you want to get up to 80, it'll cut that 70% charging in half if you double the voltage of the system. So it's clear to me that by 2028 or 2029, we're going to be at 1,500 volts in the EVs, the current ones. So we're looking at when I'm developing new connectors, I want it to be 1,500 volt connector. And then the other really disruptive or new technology is all the energy storage systems, particularly at the grid level. And they've got these they've got these battery farms that have racks and racks of batteries in them. And for both energy storage and for the EV market, they want higher voltage, because higher voltage does not reduce the shelf life or active life of your battery. And so that gives you higher wattage, higher power. If we instead were increasing the current creates heat because it's not fully efficient, and the heat actually is detrimental to your batteries, whether it be your car battery or the battery in the grid, and they fail sooner. So those are some of the trends that we're looking at.
That's a very interesting point you make there, Pat, about voltage, and something I've seen. I guess I've seen it in the specs, and I've seen how that's developed, but I guess I hadn't put it quite in my mind, and maybe some of the listeners hadn't quite in my mind about that's the reason why, right? Much better for a performance heat management point of view and longevity of the product to increase voltage versus current. That's a very interesting point. Thank you.
Yeah, John, 5 years ago, we weren't really thinking about it. We were 600 volt connector and put more amps through it. Everybody was happy with that, but we sort of got a new paradigm.
That's great. And for the consumers, that will definitely be very, very helpful. And a lot of the audience that we're trying to get out to are the design engineers designing in these products. Can you talk a little bit about, I know there's been a lot of buzz about Molex PowerWise. Can you give us your viewpoint on PowerWise?
Sure. So I think it was in March that we released the latest version of PowerWise. It's the 3.4 millimeter PowerWise. It's a 2-circuit wire to board, wire to bus bar system, well, mostly wire to board. And it gets up to 75 amps. It's a 600 volt system, which is I think it's the lowest voltage system that I have. And it's just because we made it small. And when you're working on the voltages, you've got to look at the creepage and the clearance primarily at the PCB level. And so we can do some tricks. You can put a slot in the PCB between the pins to increase the voltage, but there's some limitations when you go with a really small part. So it's a 75 amp, 600 volt system. The headers are LCP, so they're reflow compatible. It's designed to be a surface mount part, pin and paste surface mount. it's color coded. We made two versions, John. So we've got a black part and a white part, and they don't intermate. So there's black receptacles and black headers, right angle and vertical headers. And then there's a matching or nearly matching white version. And the white parts don't mate to the black and vice versa. So if somebody has a design where they have to have two cable assemblies on a board or two cable assemblies in a device, it's a way to make sure that your operators, when you're doing the system integration, don't mismate them. And then the headers by themselves are polarized. So the white header won't go on the board layout is slightly different. We've done that with the locating pegs between the black and the white header. So a black header won't go on the board where a right angle would go and vice versa. And that's just to help when they're doing building the PCB, that the operator again doesn't make a mismounting error. And you do all this because if they do miswire them and when the system gets energized, it'll burn. And then you've lost your device. Some of the other things that we're looking for, the new products that we're releasing, everything we're releasing is low halogen because that's clearly a trend, really driven heavily out of Europe, but it'll be across the whole world. So we're making sure that the products that we make today do not have halogen in them, so they can have a very long useful life into the 2030s. Almost everything that we do is touch safe, touch proof, finger safe, so that because as the voltages go up, once you get to 400 volts, if somebody touches something, they can die. It can kill you. And we're seeing the voltages run much higher than that. So you've got to make sure that your connectors, nobody can stick a finger into it in any way and actually touch a live piece of plastic. So that's some of the stuff that we've built into PowerWise.
Excellent. And what about your second product that you're pushing, Hypercube?
Yeah. Okay. So Hypercube it's a single circuit connector. We make three different colors. So we've got a blue versions, white versions, and black versions. And that's again by color coding it makes sure that the operators they've got a visual cue to make the white cable assembly to the white PCB receptacle on the board, the blue to the blue, the black to the black. So it's a way to make sure that they're not mismating the cable assemblies. It's one of the things you can do once you do make individual circuit parts, you can space them farther apart on the board. You don't worry about the pitch so much of the connector. Like PowerWise, the pitch is fixed for those two circuit parts. So for Hypercube, we've got it rated for 1,000 volts. And it is a system where the other thing that we did with Hypercube, we reversed the normal gender. So all the connectors are, maybe I won't say all, but 99.9% of the connectors that the three of us guys have ever seen, the receptacle, the socket is on the cable side and the pin is on the header side, whether it be a straight header or a right angle header, that's where the pin goes. With Hypercube, we reversed it and the socket is actually on the board side and the pin is on the cable. What that gets for us is we're able to reduce the PCB real estate of the part by about 30, by about 2/3. There's only about 35% of the PCB real estate. So it gets into really small spots and everybody knows PCB real estate is expensive. So if you can have a connector like Hypercube is a 6mm part, the pins are 6mm diameter, they're good up to 120 amps. It's about, the PCB receptacle is about the size of the last joint of your pinky finger. It's a little bit shorter than that, but it's good enough for seeing as how this is a podcast and not videoed. That's the best you can do to imagine it. And so it's also that product is touch proof, finger safe when they're mated. It's low halogen. It's also got air proof PCB receptacle. So the blue receptacle on the board only goes into the layout for the blue, the black to the black, the white to the white, and it's all designed to be poka-yoke. That's which I'm sure most of the people listening are familiar with that. It's a Japanese concept that it makes it air proof. So it takes human error out of the equation.
Very helpful. And then to bring us home here, what about Sidewise?
So The PowerWise released in March. Hypercube is released in June. Sidewise is releasing in July. So based on when this is happening, Sidewise will have already been released. That is it's a wire to panel system. We did where the receptacle side are right angle. So they'll mount onto the bulkhead connector that's mounted to a chassis, and there's no cable bend radius. It comes straight up or down. The actual connector is designed so that it can rotate 360 degrees. So whichever direction, whichever angle you want the cable to leave the back of the chassis from, or if it's the front of your chassis, it'll go in any angle you want. It's the first version that we're releasing now is one that's good up to 80 amps. It's good up to 1500 volts. There's two complementary UL safety standards now for voltage. There's UL 1977, which is the one that the three of us are familiar with for the last 20 years. That goes up to 1,000 volts. So we rated it to UL 1977 up to the 1,000 because that's all that allows. And then for the new one, the new standard is UL 4128. And that's really more because of the batteries, whether they be car batteries or batteries for energy storage. And we've rated it for 1,500 there. And it's just a newer standard, and it goes to a higher voltage. We offer this product in 3 colors. It's in orange, it's in black, and it's in red. And we did a lot of the same ideas on air proofing it to make sure that you can't mount the cable to the wrong bulkhead. It's touch proof, finger safe, low halogen. One of the things that's unique about Sidewise is the side that mounts to the bulkhead that mounts to the chassis. We have a gasket in there. That's an IP67 seal between the connector and the chassis. So you don't have to worry about condensation getting in. If it's being splashed, you don't have to worry about that. The connector itself, the interface is not sealed, but we made sure that we seal to the box so that it's not a egress point for liquids. That's probably a good, real quick rundown of Sidewise.
Pat, thank you for that. That's a lot of innovation and new technology that Molex are bringing into the power market. If I was to ask you another, maybe a leading question, but how do you see the power products and the offering from Molex developing over the coming, say, 12 months?
We're expanding all 3 of these families. This is probably where a lot. I also have another product that a year from now you can invite me back for a 3rd time, and I'll talk to you about that, John. But for these 3, we're going to be pushing them in a couple different directions. We're going to make additional current versions. We'll make smaller and larger versions. So, like for the PowerWise, we started with an 80 amp version. We're going to go ahead and do a 120 or 140 amp version. It'll be on like a 6 millimeter pitch or 6 millimeter size. So it'll be a larger pitch. It'll be a higher voltage. It'll be 1,000 volt system. We're tooling wire to wire and wire to panel versions of PowerWise right now. So that in the next 6 months, that we'll be doing a second release on PowerWise so that people can, whether it be they'll be wire to board or wire to wire. For Hypercube, there won't be anything in the next 6 months. That's a longer term. For Sidewise, we're already developing an 8 millimeter version that'll go up to 200 amps. We're developing that's towards that 12-month period, probably 6 month for the existing size that goes up to 80 amps. We're coming up with pin headers that are also touch proof, and they'll be good up to 80 amps or maybe 85, maybe 75. We'll test it when we get there, but I'm assuming that there'll be an 80 amp wire to board as well as a wire to panel version of Sidewise released before Christmas.
Exciting stuff, Pat. Thank you very much for sharing that. So, as I think our listeners are getting a feeling here, obviously, with what's driving it and the markets and some of the technologies and the demands that we're starting to see from areas like AI and EV and energy storage. This is a strong market, a lot of new products coming through, and Molex are being very innovative and driving that. So we appreciate that. Maybe some final thoughts, Pat, as we wrap up today's podcast for the listeners.
For myself, I'm always looking to meet with customers. I get great ideas from customers. I was in Portugal a couple months ago talking to a customer about Hypercube, and he gave me a great idea for a alternate version of Sidewise. So yeah, I think you've just got to keep your mind open, whatever your job is in life. For these type of products, there's a tremendous amount of new development going on with our end products. The energy storage market is exploding. The AI market's exploding. And that's giving us lots of opportunities for whoever we are and whatever our products are. It's going to give us a lot of opportunities. It's just sort of incumbent on us to try and think outside of the box. That's what the best part about my job is that I get to think outside of the box, and I'm trying to develop things that I think customers are going to need 4 or 5 years down the road.
No, I think it's a good philosophy, what you're doing. I think you're always trying to broaden your experience, get in front of customers. I think that's very important, and that's something for us all to remember, and something that obviously TTI and Molex do very well. I think always thinking outside the box is don't worry about what the limitations are today. Where's the market going, and how do we solve that problem? So I think that's a really good way to wrap up, Pat. So great having you back. Thanks very much for joining us today, and maybe we do look forward to a Pat Killian version 3 in a year or so.
That would be great. You take care. Thanks for inviting me.
Thank you.
Thanks, Pat, and thanks, John, and thanks very much to our listeners for joining us today on the Molex TTI series of podcasts, Big Ideas and Little Known Facts in the World of Connectors. Look out for a new episode coming soon.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.